Let's see some of the directions for the pre-quiz 20.2. Okay, the first one, you've got 18.2 amps of current flowing east. So here's our current right here. Okay, and then the magnetic field is 17 degrees east of north. So there it is, right? So when you're solving the problem, you be careful you don't use 17 as your angle. It's 73. It's actually this angle right here, right? Okay, so now what we do is we take our finger, right, and our index finger is the direction of the current. This is the direction of the magnetic field, okay? And then my thumb is pointing straight up. Okay, now since this is a map problem, I call these map problems. Okay, I don't say out of the page, I say up because it's the direction up. If that's east and that's north, then this direction would be out of the page, would be up, straight up. Okay? So now we got another map question here, right? A 4.2 amp current flows north in a wire that's 12.2 centimeters long, right? So the current is flowing that way, right? There's our I. Okay, what is the magnetic field if there's a vertically upward force? So the force is up. Okay, so now we got to go, okay, index finger that way, right? Now this is kind of IQ on the line. My thumb has to be up. Okay, it's a vertically upward force. The current's flowing that way. It seems like my magnetic field is going to the left, which would be west, right? Because it's north, south, right? West would be that way, right? So that's why it's west. All right. Electrons. Electrons are evil because they've got a negative charge, and so they're going to be opposite. Okay. Remember that force is QVB, right? If Q is negative, then the force is opposite the direction of the right hand, or use your left hand. Or no, wait, don't do that. Okay. So it's traveling to the north. Here's our electron traveling north. Okay. And there's a force vertically downward, so force is X. Right? Our force is down, so let's go. Here we go, right? Okay. So the velocity is up the page. My force is straight down. My thumb is into the page. Make sure you're using your right hand, okay? My magnetic field is pointing to the east. It's pointing to the right. Okay? Here's east, here's north. Here's west, right? But it's really negative east because it's negative charge, right? So it's negative east is west. And that's why it's west. Okay. Now, when you do these guys, my clue to you is look at this problem here. We want to say have it go up the page, right? So let's draw a picture of it going up the page here. Protons are positive, electrons are negative, so look it up, right? The mass of the proton will be in your data packet, so look that up. And you know the math here is not that hard. I'm just doing the direction here. So the magnetic field is out of the page, like this, right? And let's have this thing go up the page, right? So if I go like this, if I go index finger that way, middle finger out of the page, this is the velocity, this is the magnetic field, right? The force will be to the right. Of course, that's going to make this thing go clockwise. It's going to go that way, right? Okay, a force to the right makes you turn right. That's very simple, right? So that's why this thing's clockwise. Okay, and then if we do the direction of this thing, right? Well, if the magnetic force is here, the electric force would have to be that way. So your electric field would be to the left. Now, just be careful. If it's an electron, all of this is reversed. Okay? I hope that helps. It'd be so sad if that actually confused you more.